Hi, I'm Swarupa Sain, course instructor for fluid mechanics. In this presentation, we will learn how to analyze fluid motion. But before that, we will find out what is energy and what is energy equation. Energy is the capacity to do work. There are three types of energy. First one is potential energy, second is kinetic energy, and third one is pressure energy. Before going through all those three types of energy, we will find out what is potential and kinetic energy by watching this video. So now we have understood that potential energy is the energy possessed by a liquid particle by virtue of its position. And potential energy is equal to weight into the distance at which the particle is located from a specified reference datum line. Now for example, let us consider a liquid flowing in a pipe, and in that flowing fluid, let us imagine a particle being located at distance z from horizontal datum. So potential energy possessed by this particle will be weight into z. Weight is nothing but mass into acceleration due to gravity. So mgz is the potential energy possessed by this particle by virtue of its position. So that is what is mentioned here. If a liquid particle is z meter above the horizontal datum, the potential energy of the particle per unit weight will be potential energy divided by W, because it is per unit weight. So divided by W will give us the potential energy of particle per unit weight. So mgz divided by W will be equal to mgz divided by weight is nothing but m into g, that is mass into acceleration due to gravity. So we will get it as z per Newton of the liquid. And if we want to find out what is potential head of the liquid at this point, then it will be z meter of the liquid. Next we will find out what is kinetic energy. It is the energy possessed by a liquid particle by virtue of its motion or velocity. If a liquid particle is flowing with a mean velocity of v meter per second, then kinetic energy is equal to half mv square, where m is the mass and v is the velocity of the liquid particle. And the kinetic energy of particle per unit weight is equal to kinetic energy divided by W. Kinetic energy is half mv square and W is m into g, where m is mass and g is acceleration due to gravity. So this will be equal to v square by 2g per Newton of the liquid. And velocity head is written as v square by 2g meter of liquid. In the video, we had seen the potential energy as the energy being possessed by the water stored in a dam, and kinetic energy is the energy possessed by the liquid when it starts flowing. So here we can see the penstock, which is nothing but a pipe through which the water flows from reservoir onto the turbine. So when water flows on the turbine, the energy gets converted into mechanical energy as there will be rotation, and this mechanical energy will be converted into electrical energy. Next is pressure energy. It is energy possessed by a liquid particle by virtue of its existing pressure. If a liquid particle is under a pressure of P Newton per square meter, then pressure energy of particle is P by W per Newton of the liquid, where W is the specific weight of liquid, and pressure head of liquid is equal to P by W meter of liquid. From hydrostatic law, we had seen that if we consider a liquid in a container, pressure at the surface will be taken as 0, assuming atmospheric pressure equal to 0 on top surface. So here on top, P will be equal to 0, and P is calculated by knowing the specific weight of the liquid, that is W, and height of the liquid. So here H is equal to 0 and P also will be equal to 0. And as we move down H value increases. So we can see that pressure goes on increasing as we move downwards due to increase in height of the liquid. So H will be P by W. H is nothing but pressure head of liquid. So pressure head is given as P by W. So here P is 0 and here P is maximum because H is maximum. Now the total energy is given by the total head H of a liquid particle in motion is sum of potential head, kinetic head and pressure head. So H will be equal to sum of potential head, kinetic head and pressure head. Potential head is denoted by Z, kinetic head by V square by 2G and pressure head by P by W. So the total head H at any point will be potential head plus kinetic head plus pressure head. Now here in this slide there is a pipe being shown whose diameter is D1 at inlet and diameter is D2 at outlet. Here as we move along the length of the pipe, the diameter has decreased. So there are two diameters D1 and D2. Let V1 be the velocity of liquid flowing through this pipe and V2 is the velocity of the liquid at outlet. So V1 is the velocity at inlet and V2 is velocity at outlet. Here there is a pressure gauge which is fixed in order to measure the pressure of the liquid at section 1. So P1 is the pressure of liquid at section 1. Similarly, P2 is the pressure of liquid at section 2. Now the head at section 1 H1 must be equal to head at section 2. That is H1 equal to H2. Here there is one more term which we need to define, that is datum head. Datum head is nothing but the distance between center of this pipe and the datum line. Here this green line shows the reference line or the datum line and the distance between this datum line to the center of the pipe is H1 and the distance between the datum line and the center at section 2 is H2. So by Bernoulli's equation, the head at section 1 should be equal to head at section 2. Bernoulli's equation we will discuss in further presentations. So as of now, we will check out what are the terms involved in this equation. H1 is nothing but the total head, which is sum of pressure head, that is P1 by W. W is nothing but specific weight, which is equal to density into acceleration due to gravity. So W is equal to rho into G plus velocity head. Velocity head is V1 square by 2G and potential head can be either written as H1 or Z1. And this H1 is equal to H2. So H2 is the head at section 2, that is the sum of pressure head, which is P2 by W, that is rho into G, plus velocity head V square by 2G and datum head, that is H2 or Z2. Next we will find out what is law of conservation of energy. It states that energy can neither be created nor be destroyed, but it can be transformed from one form to another. For example, potential energy can be transformed into kinetic energy, but there won't be loss of energy in reality. We had seen that The water in a reservoir gets converted into kinetic energy when it starts flowing to the penstock in order to flow over the turbine. Sometimes it is referred to as energy losses due to friction, but in fact the friction transforms some energy into heat, so actually there is no loss of energy. Thank you.